Today we are going to write the equations of lines, and if you remember, slope-intercept form is y equals mx plus b. M and b are numbers and x and y are variables, so x and y will still be in your equation there. M is the slope of the line and b is the y-intercept. So y-intercept is where it crosses the y-axis. And the slope, if you remember, is rise over run. But we also have a slope formula if you are given 2 points, y2 minus y1 over x2 minus x1. Okay, so let's go ahead and look at this first part. It says state the slope and the y-intercept of the given line. Well, if it's y equals mx plus b, the number in front of the x is your slope. The b is off at the end by itself, that's the y-intercept. So here the slope is negative 1/3 and the y-intercept is 7. Number 2, we could put a plus 0 off at the end. The slope is 3 and the y-intercept is 0. For number 3, you actually have to put that in slope-intercept form first. So we're going to subtract 8 from both sides and get 2y equals 2x minus 8. But then you have to divide everything by 2 and you get y equals x minus 4. I would like you to finish this problem for tomorrow. And then number 4, y equals 10. I would like you to try that one tonight as well. But number 5, this one is special. This is actually a vertical line. And a vertical line is not going to pass through the y-axis unless it is going through 0. So there is no y-intercept. And the slope is going to be undefined. Okay? And if we just sketched a little graph of this, x equals negative 3, 1, 2, 3, you could see that it does not cross the y-axis. And if you did rise over run, from one point to the next, you could rise any amount you want and run 0, and anything over 0 is undefined. You cannot divide by 0, so that's why your slope is undefined there. Okay, so now we're going to go in the opposite direction. This time you are given a slope and a y-intercept, and you are going to write the equation of the line. So if this is your slope, this is m, and your y-intercept is negative 5, that's your b. So y equals 3/5 x minus 5. Okay, number 7, m is negative 17, so your slope is negative 17. Your y-intercept is 0, so y equals negative 17x plus 0. And if you don't put the plus 0 on there, that is perfectly okay. I would like you to try 8 and 9 for tomorrow, please. Okay, number 10, 11, and 12, instead of given information written out, you have a graph that you're going to pull information from. So you want to look for a slope and you want to look for a y-intercept. Here, your y-intercept, or where it crosses the y-axis, is negative 1, so b is negative 1. And then if you look, another nice crossing point is here and here. And between these 2 points, you can rise 2 and run 1. Rise 2, run 1. That means that your slope is 2, or 2 over 1. The equation of the line, y equals 2x minus 1. I would like for you to try 11 and 12. Okay, looking at the 13, 14, 15, if you're not given a y-intercept or a slope, you have to find that. Okay? So in number 13, it looks like, blow this up a little bit, we have some nice crossing points here, but we don't know exactly what our y-intercept is. So we can calculate this. Our slope is up 1 over 2, so our slope is 1/2. Okay, now let's pick one of the points to use. I'm going to use this point 1, 2. And that's going to be my x and y. If we plug in to y equals mx plus b, y. We know y is 2. We know our slope is 1/2. We know that x is 1, and we can find b. 1/2 times 1 is 1/2. And if you subtract 1/2 from both sides, you get 1.5, or 3/2. So now you have your m, and you have your b. So y equals 1/2 x plus 3/2. Number 14, you're not even given a graph, so you don't have the slope or the y-intercept, so we have to find both of those things. Here's where the slope formula comes into play. M equals y2 minus y1 over x2 minus x1. I'm going to start by labeling my coordinates. I'm going to say x, y, because they always go in alphabetical order. I'm going to call this my first point and my second point. Plug in. So I've got 7 minus 3 over 4 minus 2. 7 minus 3 is 4. 4 minus 2 is 2, and if we reduce that, we get a slope of 2. Just like we did in the last problem now, we have to find the y-intercept. And I'm just going to use this first coordinate, and it does not matter which coordinate you use now, but I'm going to say that y is 3. The slope we just found is 2. X is 2, and now we can solve for b. We're not plugging in b, we're finding b. 2 times 2 is 4, so if I subtract 4 from both sides, I get b equals -1. So now I have a slope, I have a y-intercept, and the equation of the line is y equals 2x minus 1. I would like for you to try number 15 for tomorrow. Okay, let's look at number 16. These are special cases. These are horizontal and vertical lines. And what I would do is I would sketch a graph for these. Just sketch them real quick, plot some points on there. Remember that a horizontal line is going to be y equals some number, and a vertical line is going to be x equals some number. So go ahead and try both of those, number 16 and 17, for tomorrow, please. Okay, let's look at parallel and perpendicular. Parallel lines always have the same slopes, whereas perpendicular lines, their slopes are opposite reciprocals. That means flip and change the sign. Okay, so for a parallel slope in this chart, it would be exactly the same as the given slope. So parallel slope here would be 7, and perpendicular would have to change the sign, so from positive to negative, and it'd flip it. So instead of 7 over 1, 1 over 7. -1, parallel to that would be -1. For perpendicular, change the sign to positive and flip it, but 1 over 1 stays 1 over 1, so it's just going to be +1. -3 over 10 stays -3 over 10 for parallel. Change the sign to positive and flip it for perpendicular. I would like for you to try the last two for tomorrow. Okay, determine whether the given lines are parallel, perpendicular, or neither. So we're looking for the same slope, opposite reciprocal slopes, or neither. Okay, so I would put both of these equations in y equals mx plus b if they're not already, and then compare. So for the first one, I see 7 and -7. Are those exactly the same? No. Are they opposite reciprocals? Well, one is positive and one is negative, but are they flipped? No. So this is neither. Let's look at 19. The slope here is -3 over 2, but for the first equation, we have to put that in slope-intercept form first. So I'm going to subtract 2x from both sides, and then I'm going to divide by -3. Notice a negative divided by negative is a positive. Here, I get 2/3. So I've got one negative, one positive. I've got 3 over 2 and 2 over 3. Those are opposite reciprocals, so those are perpendicular. I would like for you to try number 20 for tomorrow, please. Okay, write the equation parallel to this given line through this point. Okay, so they give us a point and they give us a slope. Just like above, this is my x, this is the y, this is the m. If we plug in y, m, and x, and plug it in as 3 over 1, we can find b. 2/3 times 3 over 1, these 3's cancel and you just have 2. And if I subtract 2 from both sides, I get b equals 5. So I have a slope, 2/3, and a y-intercept of 5. Final answer. Like for you to try number 22 for tomorrow. And then finally we are going to write an equation that is perpendicular. So again, we have x, we have y, and here the slope is 7 over 5. That means that we are going to use the slope of negative 5 over 7 because we want it to be perpendicular. So we had to flip it and change the sign. So if we plug into y equals mx plus b, we get 1 equals negative 5 over 7 times x, which is 14 over 1, plus b. So 1 equals, I'm going to reduce this to negative 10 here after I multiply, plus b. If I add 10 to both sides, I get b equals 11. So again, we have a slope and a y-intercept. Y equals negative 5 over 7x plus 11. Please try number 24 for tomorrow.